Hey, what's up guys? Welcome to e-bike builds. This is my Electro & Company powered Apollo RFZ dirt bike. Did this conversion over the winter and into spring of this year, and it's an absolute monster and I really love running it. I need more battery. The one that I've got in there right now, 72 volt 32 amp hour. Really good battery, but I also use that battery in some of my other bikes and I'm tired of swapping it out. So I'm going to build a new, bigger, dedicated battery for this bike, and I'm going to show you the process that I go through to build high capacity, high discharge lithium batteries. So let's go inside and I will show you how these things are made. So welcome to my little electrical shop of horrors down here. I'm going to walk you guys through my process of building a new battery. It's going to be a 72 volt battery, so that's 20 series, and I'm going to be doing 10 parallel. And I've got my supplies ready to go. I've got my welder. I know, it's not a K-weld. Sorry, it's what I've got, but it works, and I'll show you that it works here in a minute. We've got QS8 connectors for the battery cables once we get it together. Kapton tape, fiber tape. We're doing the copper nickel sandwich technique, so I've got my copper sheet, I've got my nickel, I've got my big chunky ANT 240 amp BMS and a rat nest of BMS leads. We have got, shaky. We've got fish paper, cell holders, double-sided tape, cable. Most importantly, we have got battery cells. We've also got our insulator rings for the individual cells. Now I said this was going to be a 20 series 10 parallel battery, so I'm going to need, by my math, 200 batteries? Yeah, 200 cells. I've got, wait a second here. There we go. Alright, so one of the first steps I like to do is go ahead and put my insulator rings on before I even take them out of the box. Just, it's a whole lot easier to do it while they're all in the box and upright like this and all together. And this is a very critical step. Needs to be done. Easiest to do it now, so we're just going to go ahead and do that. And this is actually great fun for the whole family. You can enlist kids to put on the stickers for you. Kids love stickers, don't you, honey?
Yes.
Stickers are the best.
Can you take this off? Can you take this off? Really? That's good.
Alright, now we're going to want to go through and check the voltage of each individual cell. These are brand new cells. They should be all very close in voltage, but these things are kind of like the old-timey Christmas lights, where if one goes bad, the whole thing ain't going to work. So this is a very quick and easy thing to do, and it's good insurance just to make sure that your voltage is exactly the same on every single cell before you start assembling the pack. So I'm arranging my cells in this kind of offset honeycomb pattern. It's a really good space-saving way to do this. My cell holders, didn't buy the ones with the clips. These are just kind of like tray holder things, but they do work for cell spacers. Fit in quite nicely. Since there's no clip or any way to join these together, what I use is some Scotch double-sided tape. This stuff is quite sticky. It holds the cells together really well. I just run a piece right down the center of each one. Get my dang on cell out here. And I go stick it in there. Ain't coming out. Alright, that should give us our template. We're going to make a whole lot more of these, because every series connection gets one. just making up the last few welds on this half of the pack. This does start getting heavy after a little while because that's a lot of weight. I just put a couple of rolls of tape here to help hold it up so I can get under there easy. And we just give our last couple of spot welds. And now we have half of the battery done. And we're going to build this thing in 2 halves and fold it over to make one big square block. Do that for safety. So everything's connected up just right. We should have our voltage correct. $34.5. Alright, we got our 2 halves welded up together here. Next step is I need to put little tabs on here for the balance leads. So the BMS, it actually even just tells you right on here, you know, 1 negative, 1 positive, 2 positive, 3 positive. I've gone ahead and labeled on my battery. This is the main battery negative, so we've got 1 negative, 1 positive, 2 positive, 3 positive, so on and so forth, all the way up to 20. So each of these wires goes to its corresponding row of cells. So I just need to add a little extra tab on here that I can solder these two to get good connection. Alright, we got the tabs on here for the balance wires. That's just another little piece that I spot welded on there. I went ahead and put a double layer of Kapton tape underneath each of these. I may even end up sliding some plastic or some fish paper under here. Just don't want, you know, this is going on a dirt bike. I don't want all the vibrations and banging around that it's going to do to, you know, wear through there and cause a short on the side of this battery. That would not be a happy day. So all we have left to do on this now is we actually have to join these 2 packs together to make one large pack. Alright, we're going to be covering this with Kapton tape and putting layers of fish paper, plastic, everything else between these. But honestly, I think this is so pretty. I hate covering it. It's just the steampunk coming out in me, but I love that look of the copper. Yeah, well, time to cover it. Alright, so we got our 2 halves made up. I've got Kapton tape covering copper on either side. Joining these 2 halves together is a fair bit of work, but it's not too bad to get done. So between the 2 halves, you could use just regular fish paper. I'm opting to use some, I think this is PVC or, you know, just some sort of plastic barrier, just as an extra level of protection between the 2 halves. Again, this is going on a dirt bike. It's going to see quite a bit of vibrations and stress and being banged around, so I feel like the plastic's just going to hold up a little better than paper over time. Not that there should be much movement in here, but there could be. So we got the plastic between the 2 halves. Now we've got positive and a negative. We just got to bridge that. And for that, I am gonna use the fish paper for that. I've got positive on this side. For the paper, I made a little fold lip on this side just to go over the edge here. I know I've already got insulator rings, but we're gonna put the paper over the edge as well. Basically, this is going to sit in the bike upside down from where it is now. This is basically the bottom, so it's going to be riding on this. So I want as many layers of protection on here, since that's going to see the most stresses in its cradle on the bike. So essentially, the paper's going to go on here, and it took a little while to get these all shaped properly because I don't have a piece of copper wide enough to do the whole thing, so I had to cut. Also, since these are honeycomb style, you know, they don't quite line up straight. I can't go straight across. I have to do slight angles and goofy shapes on this. So on this one, you can see I've got that little extra tab on that side. So when I put it on, we're catching this corner, comes over to catch that corner. And we're just putting these on just like that. I'm going to tape this down and then these are going to get tacked on the exact same way everything else has, with a strip of nickel plated steel, and that's going to join our two halves together, and at that point we will have 72 volt battery. Okay, we've got our two halves joined together. You can see I've started putting some fiber tape on here wrapped around. That was just to hold these together, make it a little bit easier to handle. I'll be adding a lot more of that as we go, just to add some structural stability. You can see the only difference I did on this part here is I used one continuous strip instead of the angled pieces there. Just made more sense since we're only joining, you know, one string of batteries there. But anyway, so we basically have a wall of copper from negative to positive at the halfway point, and that joins us together into the brick. I've still got I've got my tabs up here for getting the leads on for the BMS, and we'll be getting to that part soon enough. It's starting to take shape. Alright, every single cell was at pretty much 3.45, so we should be at 69 volts altogether. We're at 69.1. Everything good so far. Alright, so I'm going to get into putting the balance wires on now. You don't want to run the wires directly over the surface of the battery cells. That's not good, you know, if it wears through, could wear through the wire, could wear through the side of the cell and cause a short, so we're going to put fish paper down between them. It's a little bit more difficult with this, you know, kind of honeycomb style of battery, because we got to get this to match the contour of the actual battery. So what I did is I went along and I put double-sided tape along this whole stretch. You can get the fish paper that has adhesive backing. That would probably be a little bit easier, but I didn't order that. I ordered this, forgetting that I had to do this part. But we're just going to have the little tabs here for the balance leads bent up out of the way, and I'm just going to put this right on there, and then we bend our tabs back over onto here, and that way I've got a nice clean surface to put all my balance leads on as I solder them together. So I'm gonna. Okay, the majority of my balance leads are in place now. I still have the two that go to the battery positive and one that goes to the battery negative. Those are not connected yet because I do not have my positive or negative main hookups done yet. However, I am working on those, and I've got my first one right here. This is two 6-gauge wires. It's actually some SO cable, just a sheet of copper, and focus. So I spot weld them on and then also solder them on, and I'll show you my process of doing that here in a minute. It takes quite a bit of heat to get things to solder onto this heavy gauge wire, and the copper just sucks heat away. But now that I have that made up, you'll kind of see what I'm doing here. That's going to sit right on the battery. We can then spot weld the copper to the negative of the battery terminals, and then we have our cable connected without ever having put all the heat of the solder connections on our cells. So I'm using 2 strands of 6-gauge SO cable for my battery cable. First thing I'm going to do is I'm going to tin these, solder these together, because I'm going to basically be stripping these off and making one solid strip here. So I've got just a single copper wire twisting these together just to help hold all the strands together, and we're going to flux it generously. I'm going to use my heavy-duty Thor's hammer soldering iron here. This heavy gauge copper wire just sucks the heat out of anything. This is the copper sheet that's going to go on the battery positive side. I went ahead and drew a line on here and put a B on this side. This is the part that's going to be welded with the nickel strips onto the ends of all of the cells. This is the strip here that's going to get the main wire onto it. So I've got my tin wire on here. I've got it stripped off to the length of this. We're going to take our nickel strips, and I'm just going to kind of smash these into a C shape, so you can see they go right over the wire like that. I'm going to go along, I'm going to make a bunch of these, and we're going to pre-tin these. We're going to tin the wire, and then solder them together, and then tack weld them in place. Alright, I've spot welded each of these 5 tabs on there. I'm just going to go along now. I'm going to tin over each of these spots and basically just get a whole lot of solder down in here to make sure we've got really good connection at each of these points. And of course my camera cut out while I was finishing this up, but you can see got good penetration, good contact at each of the points. Should be good to go. So I've got my main positive and negative wires here. We're going to go ahead and get these spot welded on. Just like with the copper sheets that I used to join the 2 halves together, we're going to put fish paper down under here. And again, I've got a little lip of paper folded over to go over on the positive side. Let me turn this battery around. I just wanted it to lap over this very edge here, give just that little extra layer of protection. This is for the other side, but just go on there. So I'm going to tape this down, spot weld my wires on, and on to the next step. Battery negative is on. I used a double strip of nickel. So we've got negative, positive. I've got the last couple of balance wires for the BMS tacked on appropriately. I used my voltmeter to check from negative and counted all the way through all 20 series. Voltage is correct on those, so those are wired properly. Now we've got the positive and the negative here. The main negative is going to hook to the negative on the BMS, and then this becomes the load negative, and the load positive comes out with that. And this is going to sit on here like this. Now this is an aluminum case BMS, so I don't really want to set this down right now because that's going to arc between my positive and negative, and that's not going to be a good day. I am actually going to be putting this whole battery inside of a box. I've got some fiber resin board. Basically it's like PCB board material. You can get it off of eBay, AliExpress, wherever. We're going to be sides, bottom, the whole thing's going to be boxed in. I'm going to box it in like that. I'm going to leave a small gap here for my balance, and that way I can mount my BMS on the outside like this, and it's separated from absolutely everything else, and I don't have to worry about any of these sharp edges wearing through. I don't have to worry about any other oddball contacts that this could have to create a short now or in the future. Astute viewers will probably have noticed that I missed a step. I have not added my charging wire. I need to add positive wire to the positive of the battery, so I just need to go ahead and solder this on. Not ideal. I'm using a lighter gauge wire for charging. I already got 10 on here, so it shouldn't take too much to get that on there. I've got a little doohickey wedged under here to get this up off of the batteries. Hopefully not too much heat will conduct through there. I've also got a damp rag I'm going to hit this with as soon as the heat is off of it. Update to where we're at now. I've got the power charging cable soldered on now. I'm going to end up heat shrinking connector on there. We have the BMS hooked up. I've got a temperature wire, the little temperature probes. I've got one on the back side and then one, I don't remember where I put it. One way down on the back side and then one on the top here. Wire comes through here. I'll tidy that up a little bit yet. That one's supposed to happen. Trim down the main battery negative, crimped on a lug, heat shrink. I've got the BMS bolted on here. This particular BMS, I found out you got to turn it on, plugging in the accessory wire. You got to bridge this with a 3-volt power source that turns this on. Took me many hours to find the proper app to get this thing set up. That was a pain in the butt. This is an ANT BMS, and yeah, finding an app that would Bluetooth pair to this, to my phone, and getting all the parameters set up on this was a pain in the butt, but it's done now. I've got all of my boards for the, I keep calling it a box, it's not really a box, it's more just a shell, but anyway, I've got all the boards cut, trimmed for that. You can see I kind of notched out things, notched out the corners for various wires and whatnot. We are almost ready to wrap this thing. Getting it cleaned up nice. The shell is mostly taped on. I'll be adding a little bit more to that. I'm running a quick test right now just to make sure this thing's going to charge okay. I've got just kind of a real cheap, low power 72-volt charger. I just stuck it straight into the charging wires for now. I'll get some better connectors on there. Obviously, that's not going to work long term. But anyway, so I've got the main negative charge wire. These two wires are going to be together. Same with the main positive. Got the charge negative, charge positive plugged in. Little light turned red. It's officially charging, doing its first charge here. I can show you. Yeah, this camera's not going to pick it up, but it does in fact say charging on the app. I still got a bunch of other settings to go through to make sure this thing's set up properly. Every battery's going to be different on that. Yeah, it's coming along. Yeah. Let's see how it shrinks on there. I've never used this stuff before. Well, may not be the prettiest wrap job, but I'd say it's pretty sturdy anyway. So this hole kind of opened up a little bit more than I wanted it to as it shrank down, so I got to figure out some way to seal that off a little bit better. But I mean, that's pretty good solid covering. I'm going to I had to trim this a little bit because it just kind of bunched up as it was shrinking. I'm going to get some probably some RTV black silicone, seal this up. Yep, I'm going to declare this done enough. I never did really get this corner sealed off quite the way I wanted to, but honestly, it's going to be good enough. So, I've got my information on here, 72 volt, 40 amp hour. It's good for 240 amps continuous, 500 amps peak. Now, the 1mm copper is probably not going to carry 500 amps, but yeah, that's what the BMS is capable of. QSA connector is probably also a little underrated for peak amperage. The bike that this is going on, and it's permanent on that bike, it's only a what is it, a 150 amp controller. It's probably not gonna, it's never gonna pull up these upper level of these amps on here. I was more interested in the bigger capacity and less voltage sag. So those numbers are, you know, take them with a grain of salt. The cells are capable of it. The BMS is capable of it. And those connections in there, maybe, maybe not. But in my application, they're never going to see amperage of that height. So we've got main battery power hookup. We've got a charging port. I did an XT90 connector on here for my my charger hookup. It's pretty well, I mean, it's wrapped, sealed it up at least around the edges there, and my final little flourish, just for kicks, just a fun little flourish. Put her on the bike, and away we will go.